detects the charges coming from the magnet, because magnets are like a closed circuit, but they're emitting the charged particles continuously. See how powerful that is? In fact, this experiment, my great inspiration was Michael Faraday, and he did this like 170 years ago, and that was called laws of induction. So what he did, he had a coil. Well, of course it wasn't like this, but the principle is the same. He had a coil, and then he moved this coil through the magnet, so he had the induction. And it doesn't matter whether I move the coil inside the magnet or I move the magnet outside the coil is going to be the same. So I demonstrate a little bit. See, it's connected to DC voltage, but you can tell when there's a movement, you can see the electromagnetic induction. If this is stationary and I move the magnet, it is going to be exactly the same. So I thought, instead of magnet, why don't I use the Earth's flux lines, or as I call it, the line of forces? So I came up with this idea. If I have, and this is consists of at least 20 coils or 20 solenoids, and each one must have at least 3,000 turns. So what I did, I connected together, and then I thought, if I rotate this, and then it cuts through the flux lines, which Earth is continuously emitting those, the electric fields, and we have the flux lines, and then somehow I can detect that. And in fact, my assumption was 100% right. And then I investigated further, and then I realized if 100 million flux lines or line of forces are cut in 1 minute, in 1 second, so there'll be 1 volt. And then what I did, I made my own gearbox with bevel gears, and then when I rotate this, well, of course, it must be like at least 1,000 RPM. And then I realized something, and then I noticed something strange. The faster, or the more RPM I have, the more induction I get. And then I compared this to the generator. When generator is going slow, or the RPM is slow, you get dimmer light when the RPM is high. And my guess was right. Now I'm going to demonstrate exactly what I mean by this experiment. So this is like a wood, and then I didn't want any interference, so that's why I made my hand torque gearbox. So when I rotate this, and it doesn't matter clockwise or counterclockwise, and then I can detect that they are cutting through the Earth's flux line, and then I can get electromagnetic induction. So this is the transducer. Now, if I hold above this, nothing will happen because it's stationary, and in fact, it's exactly moving with the Earth, or with the Earth's rotation. Now I try to. You see, the faster I rotate, the more I cut the line. If I go over here, there was less in induction. But if I come over here, it will be more. I have to adjust this a little bit. have to repeat this part because it wasn't in the picture. So like I said, these are the coils connected all together, and then when I have a relative motion with the earth, I can detect the lines of forces are cutting through these wires, and then I have electromagnetic induction. See? This is exactly like you're holding this transducer on a line wire for DC. See? When it's blue, it means we have less induction. When it's red, it means we have more induction. The reason why, the RPM. The faster I rotate, it's exactly like a generator. The more I get. See, if I get it over here in between, there is no induction whatsoever. Here, no induction. But as I get it over the lines, over the coils, you can tell we have a good induction. This is another transducer, of course. This is a paramagnetic and aluminum disc, and I also did it with copper, but the results are the same. So when it's motionless like this, you don't see any induction whatsoever. But when I rotate this, the line of forces are cutting through these holes, and this one is exactly 1 centimeter, and we can see the induction. So I show. You see? The faster I rotate, the more induction I get. But when I come over here, you see you don't see any induction whatsoever. Or very little. But over here, on those holes, you can see a lot of induction. See? So this is another way to show. See, there's no induction here, but over the holes, you can see a lot of induction. In order to rule out all the possibilities of the metal interference with the magnetic induction, I decided to do this time without any metal. So this is just like a wood, but I did exactly the same thing. Here you can tell these are exactly 1 centimeter, and then I cut through. I just made a hole all around it. This is 20 inches. So when I rotate this, and then I hold these transducers over the holes, and exactly like I said before, the line of forces are coming from everywhere. So they're cutting through, and then this transducer can detect those. You see, when it's slow, you can tell the blue light coming. When it's faster like this, it must be at least 1,000 RPM. You can see the red light. See? Same thing with this one. When I take it over here, see, there's no induction. But as long as I hold it over this, it's going to be induction. This time I used copper or diamagnetic, and the results are exactly the same. Well, of course, I couldn't find the big one, but you can tell the electromagnetic induction is the same. So when it's small, when the rotation is so low, you can see it's blue, but when it's faster, it'll be like that. It'll be red.